Hey folks, this is the Advanced Math Trigonometric Identities Homework Quiz D recap. This is where we look at the question for Homework Quiz D, but not the actual question. We're going to do a couple questions that are very similar to the question in the quiz, so that if you had trouble with the quiz, you should be able to learn from this. If you haven't done the quiz yet, these are not the answers, but maybe you can learn as well. So angle of incidence, to recap, if you have on a coordinate plane a line, the angle of incidence is the angle measured counterclockwise from the x-axis to the right of where it crosses the line. So we're measuring that angle. The angle is always measured as a positive number, and it's always going to be between 0 and 180 degrees, not including 180 degrees, so between 0 and up to, but not including 180. And we're depending upon a relationship between the angle of incidence and the slope of a line, which says that the slope of a line, m, equals the tangent of the angle of incidence. So if we want to get the angle of incidence, we just need to take the inverse tangent of the slope. Easy peasy. However, there are some gotchas, and we'll talk about that in a moment. But for the first question, it's quite simple. So y equals 5/3 x minus 3. If we wanted to sketch the graph of that, very crudely, we have a y-intercept of -3. It's a slope that's greater than 1, so it's going to look something like that, and our angle of incidence would be right there. So we very simply have to take the inverse tangent of 5/3. And if you do that in your calculator, you're going to get about 59 degrees. So that angle there is 59 degrees. That's the angle of incidence. Okay? Now, second question says, well, what if the slope is negative? So let's sketch that one out too. Here's our coordinate plane. We have the same y-intercept as we did in number 1, but our slope is going to be negative, so it's going to look something like that. And now our angle of incidence is still, remember, measured from the positive x-axis counterclockwise to the line. So it's going to be a pretty big angle. Now, the thing about inverse tangent is that it doesn't necessarily do what you want. Let's try it. So we're going to say, hey, theta equals the inverse tangent of -5/3. And our calculator says, oh, it's -59 degrees. What your calculator is doing is saying, it's giving you this angle. That's -59 degrees. We don't want that angle. We want this angle. So if you know that this is 59 degrees, what would this be? Well, these two angles add up to 180 degrees. So our actual angle of incidence is going to be 180 minus 59. So actually, our theta is going to be 180 degrees minus 59 degrees, which is 121 degrees. And looking at what I've got here, that certainly looks like, yeah, that could be 121 degrees. That makes sense. Sure, -59 degrees, I buy it, but that's not how we define the angle of incidence. We always measure the angle of incidence above the x-axis in this way. So we never use a negative angle. So you've got, when you're finding the angle of incidence, you have to do a little thinking. If I'm working with a negative slope and I get a negative angle, I need to change that to the correct positive angle. If I'm working with a positive slope and I get a positive angle of incidence, I'm good to go.